Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday night math night. I'm so excited to be here with you guys. Like Dr. A said, every Wednesday we are here just doing math together, sitting in our living rooms or our bedrooms or at a coffee shop, going through math problems that you may see on your upcoming certification exam. So, like he said, I'm Amy Sink. I'm one of the math specialists here at the Learning Liaisons. I absolutely love math. I am a little bit about me. I have a husband and a 2-year-old and a little dog. He's not a little dog. It's a Great Dane. And I am an assistant principal here in Central Florida. So let's get to know each other a little bit more. It makes it feel slightly less like a computer screen. So let me know where you're from. What test are you prepping for? That helps me understand what rabbit trails I need to go on. And get to know you question. Are you traveling for the holidays or no? Do you travel for Thanksgiving? Do you travel for Christmas? Let's just talk about Thanksgiving. Are you traveling for Thanksgiving? Or are you staying local to wherever you are for Thanksgiving? We do not travel. We stay home. We go to my uncle's house for dinner. But we don't go anywhere. Like all of my family lives here. We are super lucky that my entire family lives here. So do you travel for Thanksgiving? And where are you from? And what test are you prepping for? Hey, Latrinda, it's good to see you. We are going to go through a variety of problems tonight. If there is something that you want to see me go over in the upcoming weeks, you can always tag me in our Facebook page. Make sure you tag me because otherwise I might not see it. And I also always have a next week section here. And so I always like to put topics or questions that people are like, hey, I've really been struggling with this. And I always like to put it in the upcoming weeks section so that we can go over it. So let me know where you're from, what test are you prepping for, and do you travel for Thanksgiving? And then in the comment box, as we're working through problems, let me know if you're like, ooh, can you do another problem like that next week? Or can you focus on geometry or functions or linear equations or whatever? And then it helps me if you give me some sort of context for that, because just telling me that you want me to go over like a super broad topic, there's often a lot that we can go over in there. And so it's just helpful if there's something specific that you're struggling with. If not, I'm happy to craft problems related to that. We're going to go over problems that span K through 12. And every problem, even if you see a problem where you're like, I don't really think that applies to me, I try really hard to make every problem relevant for everybody. So just stick around with me for the whole almost hour, and you'll definitely see problems that are helpful. I think that's it. So let's go ahead and get started with problem number 1. This was a specifically requested problem by somebody, so I usually will put a star if it's something that somebody requested, just so that you can kind of see. Hi, Sarah. It's good to see you. TExES for the EC6. Awesome. All right, let's read this problem. Use the number line below to answer the question that follows. Students in a pre-algebra class are asked to locate negative x on the number line shown. This activity is most helpful for students in their understanding of which of the following concepts. Negative x can represent an irrational number. Negative x can represent a positive number. The absolute value of x is positive, or the absolute value of negative x is positive. So, this is an interesting question. So when we're looking at this problem, I'm looking at this number line and I notice that this x is on the negative side of the number line. And so the activity is asking them to locate negative x on the number line. And that's going to trip kids up because the x is actually on the negative side of the number line. And so what kids need to recognize is that negative x is going to be right here, equidistant from 0, because x and negative x are going to be equidistant because x is going to have the same digit value that the other x does. It's just one is positive and one is negative. But kids are going to struggle with that because they are going to say, well, that's not possible. Negative x has to be on this side because that's where negative numbers live. But what they're not putting together is that negative x isn't actually a negative number, right? X is a negative number. So if x equals -3, then negative x is going to equal -3, which means negative x actually equals a positive number. And so what this shows us is that negative x can indeed represent a positive number. And that's a really, really hard concept for them to understand, but it's really critical because as they begin to operate with different functions and different values and plugging values in, they need to recognize that negative x can actually represent a positive number. For instance, if I have negative x plus 4 equals 9, and I say plug in x equals -3, when I plug in -3 into that, I'm going to end up with negative x is -3. So equals y. Let's say y, not 9. Let's say y equals y. Then negative times -3 equals a +3. So that ends up 3 plus 4 equals 7. So y equals 7. Kids struggle with that because they don't understand that a negative x can represent a positive number. They are okay with x equaling a negative number, but they often don't recognize that negative x can equal a positive number. Does all of that make sense? That's kind of like a weird concept to grapple with, right? All right, let's go ahead and move on to the next problem. That was a fun one. That's kind of a weird one. All right, next problem. If 3/4 x plus 2 equals 2/5 x minus 8, then what does negative 7x plus 34 equal? If 3/4 x plus 2 equals 2/5 x minus 8, then what does negative 7x plus 34 equal? So in this situation, really all we're doing, it sounds super complex, but really all we're doing is we're taking this, iPad just disconnected. No worries, we'll just reconnect it. It happens. What we need to do is take that original equation that we were given and then solve it for x and then plug x into the second expression. So what we have is an equation and an expression. And so we're going to solve for x here, which is our equation. And everybody needs to understand the difference between an expression and an equation. This is an equation because it has an equal sign. And then I have an expression here. And so I'm going to take my x value and plug it in to my expression. Equation and expression, two different things. So let's go ahead and solve our equation and then plug it into the expression. 3/4 x plus 2 equals 2/5 x minus 8. So I need to get all of my constants on one side and all of my x's on the other. So I'm going to subtract 2 from both sides. 3/4 x equals 2/5 x minus 10. And now I need to subtract 2/5 x from both sides. And so I'm going to be left with negative 10 over here. However, I need to figure out what this equals. And so in order to subtract fractions, what do I have to do? Find a common denominator. And so this is where this problem shifts from being more middle and high school to everybody, because elementary and pre-K through 3 people, you need to understand how to subtract fractions that don't have like denominators. So I'm going to have 3/4 minus 2/5. And so I'm going to find my least common multiple or a common multiple. If I can't figure out what the least common multiple is, it doesn't really matter. I'm going to find a common multiple here. And so I'm going to multiply this one by 4/4. I'm going to multiply this one by 5/5. What essentially did I just do? Essentially, I just multiplied by a value of 1. Anything times 1 is itself. And so what I did was I multiplied 3/4 by 1 because 5 divided by 5 is 1 and anything times 1 is itself. Following? And I multiplied 2/5 by a value of 1. 4 divided by 4 is 1. Anything times 1 is itself. And what that's going to do is it's going to give me a common denominator of 20 in the denominator for both of them, and then I can subtract. So 5 times 3 is 15. 5 times 4 is 20. Minus 2 times 4 is 8. 5 times 4 is 20. 15 minus 8 is 7/20. So I have 7/20x equals negative 10. And I'm going to put the x on the other side. Now I'm going to multiply both sides by 20/7. And you say, but Amy, why are you doing that? Because by doing that, you're like, aren't you supposed to divide because 7/20 is being multiplied by x? Yes. But here's what I want you to consider. I want you to watch this. If I have 7/20x equals negative 10, and I divide both sides by this fraction, can I divide by a fraction? Yes, but what do I have to do to be able to do that? Keep, change, flip, right? Keep, change, flip. Now, obviously, I'm going way more into detail on this problem than I would middle school and high school people if I was just solving it. This problem's taking me way longer because I'm digging a little deeper for my EC6, for my elementary people right now. This problem would be long done by now. So at this point, I am still solving this equation to find x, right? But I have to keep change flip. So what that turns this into is keep, change the sign, flip, which is really just multiplying by the reciprocal, right? That and that are the same. So negative 10 times 20 over 7 is negative, get my handy dandy calculator. I should be able to do 20 times 10 in my head, but I don't feel like doing that right now because it's been a long day. 200. Wow. How did I not know how to do that in my head? That tells you, woo, it's been a long day. Okay, so negative 200 over 7. Now, some of you are like, that does not seem right. That's a really crazy fraction. That is a really big fraction. I'm afraid of fractions. We're not going to talk like that. We're not going to do negative math talk. What I want you to realize is when we go to plug it back in, it's actually going to make our lives easier. So don't freak out that you got a fraction here just because there's whole numbers here. It might end up working itself out. Now, if it doesn't, then you might have a problem. But a lot of times it does. So let's go ahead and explore that. So negative 7, I'm going to move into this. Negative 7x plus 34. I'm going to plug this guy in for the x. Negative 7 times negative 200 divided by 7 plus 34. Are you seeing what I'm seeing? Are you seeing what I'm seeing? Those 7s cancel out. Now, if you didn't know that, you could do 200 times 7, and then you could divide that by 7, and you would realize that you would get 200. You could do all of that. It would take a little bit of extra time, but those factors cancel out. And what's a negative times a negative? A positive. So we end up with 200 plus 34, and it looks like I have a typo here, which equals 234. This shouldn't have said 243. This should have said 234. That was just a typo. So that's our answer. Questions, comments, concerns? All right, let's go ahead and move on to the next problem. Jeremiah is building a closed wooden box. He figures out that the length of the box is the square root of 30 feet. The width of the box is the same as the length, and the height of the box is 5 feet. If Jeremiah wants to paint the box and one small container of paint covers 6 square feet, how many containers of paint should he purchase to paint the box? How many containers of paint should he purchase to paint the box? So he's building a closed wooden box. So here's our closed wooden box. Right? There's our closed wooden box. And the length is the square root of 30. And the width is the same as the length. And the height of the box is 5. Now, if we are solving volume or surface area of a rectangular box, it doesn't matter where the length, the width, and the height are, because volume of a rectangular prism is length times width times height. And we all know that multiplication is commutative. Elementary people, you need to know that, which means that 3 times 5 times 4 is the same thing as 4 times 3 times 5 is the same thing as 3 times 4 times 5. It doesn't matter what order you do it in. Division is not. Addition is commutative. Subtraction is not. 3 minus 4 is not the same thing as 4 minus 3, right? So all of that said, what are they asking us for? They want to know how many containers of paint he should purchase to paint the box? Is that how much stuff can go in the box? Or is that how much area there is on the outside of the box? Which one is it? That is how much area is on the outside of the box. How many sides does this box have? How many faces does this box have? 6. Now watch how I'm going to do this. And this is how I do this to this day. I'm going to have my front and my back, which is this side and the back. What is the length and the width of the front and the back of the box? The square root of 30. So, and it looks like I might have had the wrong, we're going to just do this real quick. So, I'm going to do the square root of 30 times the square root of 30, which equals 30, right? I am completely frozen on my end, so I'm not sure if I'm completely frozen for you guys too. I'm going to keep working through problems just in case I'm not frozen. And if I am frozen, then I'm talking about this for no reason. But the square root of 30 times the square root of 30 equals 30, because the square root of 30 times the square root of 30 equals 30 squared, which is just 30. And how many of those are there? There's a front and the back. Okay, we're still live. My computer just shut down. Why? I don't know. But I'm going to reconnect my iPad and then we're going to keep going. I don't know where it stopped for you guys. So I'm just going to start with the square root of 30 times the square root of 30 once it reconnects. It's thinking, it's thinking, it's thinking, thinking, thinking. Sweet. And now my iPad is frozen, so that's awesome. Let's try this. Let me see. Let me see if this will work. Okay, this is definitely not the most ideal, but it's going to have to work for right now. I have a really hard time so what I'm going to do is I'm going to end up drawing on my computer with my trackpad, but it just makes it hard to like track it. Okay, so we've got our box. Insert a shape. Let's insert a box so I don't have to draw it. There's my box. And we talked about how this is the square root of 30. This is the square root of 30 also. And then the height is 5. The height of the box is 5. And then we were talking about how the front and the back are the same. So you have the front here, and then you have the back here that's going to be the same. And so when I solve surface area problems, I always will sit here and draw like I have a front and a back. And if I'm trying to find the surface area, which is how much paint I can put on this box, I need to find the areas of all 6 sides of this rectangular prism. So I have the square root of 30 times the square root of 30, which equals what, friends? 30. Why did I do square root of 30 times the square root of 30? Because I'm doing length times width to find the area of that shape. So square root of 30 times the square root of 30 is just 30. And how many of those are there? 2. So 30 times 2 is 60. So far I have 60 square feet of space that I need to cover, right? But then I have this side right here. And then I have like this back side right here, right? And what are the dimensions of those rectangles? So let's do that in blue. So now I have my blue rectangles. And I know that the bottom is 5 because we've got a 5 right here. And then this side right here is also going to be the square root of 30. So length times width says I'm going to have 5 square roots of 30, but there's 2 of them. So that equals 10 square roots of 30. And then I have the top and the bottom. I have the top and the bottom. And the top and the bottom are also going to be square root of 30 and 5. Because this side is 5 and this side is the square root of 30. But there's 2 of them, and we already did all of that math. So that's all going to equal 10 square roots of 32. So now I have bits and pieces and chunks of surface area, right? And I need to add them all together. So I need to do 60 plus 10 square roots of 30. This is really messy, isn't it? Plus 10 square roots of 30. So that equals 60 plus 20 square roots of 30. Now, we know that 1 container of paint covers 6 square feet. So what I need to do is I need to figure out what the square root of 30 is first. I know the square root of 30 is going to be between 5 and 6 because the square root of 25 is 5 and the square root of 36 is 6. So it's going to be somewhere in between 5 and 6. So if I didn't have a calculator, I could at least manage with that. But I do have a calculator in front of me. So I'm going to do the square root of 30, which is 5.4, times 20 plus 60. And that all equals 169.5. And what do I need to do with all of that information? Divide it by 6 square feet, because this is the total number of square feet that the box is, and that's the surface area. And if I divide it by 6, then I can figure out how many cans of paint I need. Now, this equals 28.2. So what's my answer? Is it 28 or is it 29? It's 29. Here's why. Even though 28.2 technically rounds down to 28, if we want to know how many containers of paint we need to paint the box, if I only buy 28 containers of paint, I'm going to be left with a very small chunk of my box that's not painted because I need exactly 28.2 containers of paint to paint my box. So in this situation, we would not use rounding rules. What we would do is we would have to buy 1 more can of paint to ensure that we can paint the whole box. So instead of buying 28 cans, even though 28.2 rounds down, we would buy 29 cans of paint. Does that make sense? All right, let me see. I may not be able to do these problems in order because there's going to be some of these problems that I'm just not going to be able to do with this trackpad math that we're operating with right now since the computer froze and then the iPad froze. That one's going to be really difficult. Okay, let's do this one. How many solutions and what kind of solutions does the following equation have? How many solutions and what kind of solutions does the following equation have? F of x equals 3x squared minus 21x plus 5. 2 rational solutions, 1 irrational solution, 2 irrational solutions, 1 imaginary solution, or no solutions. So in this situation, we are looking at a quadratic equation, and I'm going to just talk with my hands for a minute because I can't talk with my pen. So in this situation, we are looking at a quadratic equation of which we're trying to figure out the types of solutions that we have. And in order to do that, we could factor it. If it's factorable, then we would be able to see that we would have 2 rational solutions, right? But if it's not factorable, what we can do is use a piece of the quadratic formula. We can use the quadratic formula to figure out what kind of solutions it has. But I don't need to use the entire quadratic formula, which I'm going to snip instead of write because it's going to take forever for me to write. So the entire quadratic formula is this, okay? Whoops. Here's the quadratic formula. And it says negative b plus or minus the square root of b squared minus 4ac all divided by 2a. What does that give me? That gives me an x value for where we have a solution or a 0. And so what kind of solutions do we have? Well, if I use the quadratic formula's discriminant, which is this part right here, this is the discriminant. If I use the discriminant, I can figure out what kinds of solutions we're dealing with. So if I have b squared minus 4ac, and I figure out just that piece, knowing that this right here is A, this right here is B, and this right here is C. If I use the discriminant, if the discriminant equals 0, what does that tell me? If the discriminant equals 0, that tells me that I have one real solution, one real rational solution, because I'm going to end up with negative b plus the square root of 0. Square root of 0 is 0. And I'm going to end up with negative b minus the square root of 0. Square root of 0 is still 0. So I'm not going to end up with 2 solutions. If the discriminant is a negative number, what do I end up with? If my discriminant, that b squared minus 4ac, is a negative number, what happens? Can't take the square root of a negative number. Exactly. And because I can't take the square root of a negative number, if b squared minus 4ac, just that little piece, if that little piece is negative, then I end up with imaginary solutions because I can't take the square root of a negative number. Are you seeing how I don't have to do this entire formula to figure out what kind of solutions I have? I have to do that whole formula to figure out what my solutions actually are, but I don't have to use that entire formula to figure out whether they're positive or negative. And then if my discriminant is a positive number, then I'm going to end up with either irrational or rational solutions. So if it's like 20, I can't take the square root of 20, but I'm going to end up with solutions because I can take the square root of 20 and I'm going to end up with an irrational number. So if I end up with a number like 20, then I'm going to end up with 2 irrational solutions. If I end up with a discriminant that's a perfect square, 25, 36, 49, 100. If I end up with something like that, then I'm going to end up being able to square root it, and then I'm going to end up with 2 rational solutions because I'm going to end up being able to square root it. Does all of that make sense? So let's go ahead and find our discriminant. So b squared minus 4ac. So b is negative 21. So negative 21 squared minus 4 times a times c. 21 squared is 21 times 21 equals 441. And then minus 4 times 3 times 5, 60. 441 minus 60 equals 381. And 381, if I do the square root of that, it is not possible. Well, it's possible. We end up with an irrational number. And so the square root of 381 is 19.51922213. Now, you should, if you have this problem on your exam, you should have a calculator. If you don't, I would suggest you knowing perfect squares through 12, 13, 15, something like that. But then you can start playing with it if you're not sure and be like, okay, 18 times 18 is what? 19 times 19 is what? And you can figure it out. But because I end up with an irrational number, I'm going to end up with 2 irrational solutions. So my answer is going to be C. Questions about that problem? Is there anything that you're like, oh, I really wish she would go over this in the upcoming weeks? Let me know in the comment box. Hello, can you please review geometry word problems from the GK math? Yes, that's a great suggestion. Let's go ahead and add that to our next week text box that I'm going to type into since I don't have my iPad. So geometry word problems from GK math. Yes. Next week. That's a good one. I love that. All right. Yes, I can absolutely do that. All right. Let me know if there's anything else you want me to go over in the upcoming weeks. And we're going to go over the next problem. But I have to figure out what problem I can easily do with this whole situation. Let's try this one. The points x, -5, and 2, 7 lie on a line that is perpendicular to a line with a slope of 3. What is the value of x? The points x, -5, and 2, 7 lie on a line that is perpendicular to a line with a slope of 3. What is the value of x? -1, 3, 26, or 38? All right. So this is an interesting one. And somebody asked for functions. And while this isn't like f of x equals, linear equations are indeed functions. So I want you to remember that when we're talking about linear equations, because they fall right into the function category. So the points x, -5, and 2, 7 lie on a line that is perpendicular to a line with a slope of 3. What do we know about perpendicular lines and their slopes? We know that they have negative reciprocal slopes. Exactly. So I know that if I take the slope of this line, and how do I find slope? Y minus y over x minus x. So if I do 7 minus -5, don't mistake the -5 for the minus. 7 minus -5 over 2 minus x. 7 minus a negative becomes a positive. So this ends up equaling 12 divided by 2 minus x. And so this is the slope of a line. And this line is perpendicular to a line with a slope of 3. So if it's perpendicular to a line with a slope of 3, then what is the slope of the line that I'm working with? The slope of the line that I'm working with has to equal 1 over 3. Sorry, negative 1 over 3. The slope of the line that I'm working with has to equal negative 1 over 3. And you're like, Amy, how'd you get that? Because perpendicular lines have negative reciprocal slopes. So if the slope of one line is a over b, the slope of another line is going to be negative b over a. So if the slope of this line is 3, the slope of the perpendicular line is going to be negative 1 over 3. And so in solving this, I can just cross multiply. 12 times 3 is 36. Negative 1 times 2 minus x is negative 1 parentheses 2 minus x. And so I can distribute that negative. So 36 equals negative 2 plus x. Add 2 to both sides, and I get x equals 38. Which is D. Questions about that one? We're getting closer to the end, y'all. We're getting closer. All right, let me find another problem that we can do. Let's do this one. What is the 34th term in the sequence of numbers? What is the 34th term in the sequence of numbers? 7, 13, 19, ... All right, so 2 different ways we can solve this. We can figure out the common difference and then click plus, 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 plus in our calculator if you have a calculator. If you don't have a calculator, then you can sit and add it literally on your screen. So I could do, okay, I am adding, so 7 plus 6 is 13. And 13 plus 6 is 19. And 19 plus 6 is whatever. And so this is term 1, term 2, term 3. And I could go 4, 5, 6, 7, 8, 9, 10, 11, 12. And I could go all the way to 34 and I could sit and add 6. And for some of you, that's going to be what's best because you have a hard time remembering formulas. And that's okay. To be quite frank, between you and me, when I took my exams, that's how I did it because I don't like holding formulas in my brain. I just don't. I'm not a formula person. So if I had a calculator, some of you do, some of you don't. If I had a calculator, I would sit here and go 7 plus 6. There's 2 plus 6, 3 plus 6, 4 plus 6, 5 plus 6, 6, 7, 8. Here's the problem with that. I'm going to be honest. Again, that's how I did it. But the problem with that is it allows for a lot of room for error. There's a lot of room for arithmetic error in that. So if you can memorize a formula, I'm going to give it to you. The formula is A sub n. I'm actually going to snip it because, again, my handwriting is horrid with this trackpad situation we've got going on. So A sub n equals A sub 1 plus n minus 1 times d, where this is the term you're looking for. So this would be the 34th term. This is the first term. This is the number term you're looking for. So I'm looking for the 34th. And this is your common difference. So it's going to equal 7 plus 34 minus 1 times the common difference is a positive 6 because I'm adding 6 each time. So then I can do 7 plus 33 times 6. And then even if I don't have a calculator, the likelihood of me making an error doing 33 times 6 plus 7 is a lot less than the likelihood of me doing 7 plus 6 plus 6 plus 6 plus 6 plus 6 34 times. Because if I'm even one number off, it's going to mess me up. So 33 times 6 is 198, plus 7 is 205. So my answer is D. Questions? All right. We definitely had some technical difficulties tonight. I appreciate you hanging out with me even through the technical difficulties. I have my next week section pulled up. Let me know in the comment box what you want to see me go over in the upcoming weeks. Next week, we are going to be here. It's the night before Thanksgiving, so some of you might be cooking a turkey or doing some green bean casseroles or whatever, but we will be here. It might be a little shorter, but we'll be here. And I will see you next week for a special Thanksgiving edition of Wednesday Night Math Night. I'm going to turn it back over to Dr. A, and I will see you all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.